How do we improve the inefficiencies of water usage in our current agricultural system? 70% of water is being used by agriculture, and we are experiencing increasing droughts throughout the world due to climate change. Hi, this is Takatoshi Shibayama, the host of the Future Design Podcast. In this episode, I have Ole Kristian Sivertsen, CEO of Desert Control, who has found a way to liquefy clay and spray it on a desert so that it can grow crops. Liquid Nano Clay is being tested in the deserts of Dubai, and it's shown remarkable results, retaining water and nutrients in the sand to allow for desert farming. He'll explain to us about this technology, so stick around to the end. Well, thank you very much for coming on to our show, Ole. I've noticed your work on CNN. I read an article about desert farming, and you're using a special technology that has been invented about maybe less than a decade ago. I've read a lot of articles and research done around desert farming, which includes vertical farming, droplet irrigations, using solar energy, which is one of the really very intensive part of farming in deserts is energy, right? And also how to get water. So some are using seawater to do this, some are dipping into the aquifers. I wanted to know a little bit more about what your technology is, which is called Liquid Nano Clay, which is something I never heard of before. So first of all, thank you very much for being on our show.
Well, thanks for reaching out. Let me start with a reference back to some of the areas you're mentioning here, because there is a lot of things going on in water technology and energy, which are great innovations, and we need all of them. At the same time, we also need to look at the amount of water that farming consumes across the world. And if we look at that, more than 70% of all fresh water on the planet is consumed by agriculture and for food production. Mm. And in a scenario where the United Nations, in their reports, predict that by 2025, 1.8 billion people will suffer absolute water scarcity, I think we also need to take a hard look at how do we optimize and how do we grow better crops and more crops with less water. So liquid nano clay comes into play in that arena, really on improving the hygroscopy, or the soil's ability to both absorb and retain water and nutrients. So that's where we fit into the picture. And of course, we will need water. Water and air is crucial for all life. We're focused on making sure that the soil can retain more of the water. It's a big issue, around the world as well. With both, we hear about more extreme weather, more droughts. We have all these increasing temperatures that are causing deaths to spread, and as that happens, temperatures rise in a more vicious cycle again. So you look at sort of what's happening around the world when it comes to the loss of fertile topsoil, this really thin membrane around our planet that accounts for maybe 90% of everything that we eat and even what we wear. That thin membrane is getting thinner and thinner. And the challenge with that is that we'll have to, very, very quickly find alternative sources if we cannot reverse it. The other challenge is with regards to water is that the thinner it gets, the more mineral rich that soil will be underneath, very sandy, and that will require even more water than the 70% of all fresh water that we're consuming today. So we need to address the issue of that, combined with soil health, combating desertification, and protecting land from degradation, and really championing cultivation of healthy soils for a healthy planet. That's our target.
Yeah. So the liquid nano clay, as you said, the clay actually absorbs water so that it retains water for a prolonged period of time compared to regular irrigation methods or regular soil. Now, when you use the word liquid nano, can you explain to us what exactly that means?
Yeah, if you can imagine, it's correct as you say that clay retains more water and also nutrients when it's at the right proportions or the right concentrations. There is also a reason why we use clay in pottery, That's because at the condensed stage, no water will get through it. So you really want to get this right thing, the right concentrations and the right particle sizes of clay into the specific soil. And soil everywhere around the world is different. So no soil is the same. There is difference in the composition of how many percents of sand, silt, and clay, organic matter, pH levels, salinity, and so many factors that are different. So really what we are meaning when we're looking at it from a naming perspective of liquid nano clay is that we need to look at clay from clay and the soils from really a micro and nano perspective to understand the tiny elements of that soil in order to figure out what is the best way to cultivate that soil to make sure it becomes a healthy soil and can retain water and nutrients. And the other side is that, I mean, if you imagine, a lumpy bulk of clay and trying to work that one into the ground, that's not easy work, right?
Yeah.
I mean, I sometimes make a pizza, Italian pizza on a Saturday night, and I think it's sometimes cumbersome just to get the flour into the dough there, right?
Right.
And then just imagine this sticky, gluey thing and getting that into a porosity and nicely distributed thing into sand and soil. I mean, I wouldn't even go there and try it, right?
Right. Yeah.
So it's about sort of getting the particles to be separated from each other. So that we're talking about sort of the basic of matter and the physical properties of the particles in that clay, so that we can have them not to become that lumpy matter, to separate them from each other and to have them down to a particle size that is small enough for this clay to be able to percolate into the soil by itself in a non-intrusive way. So we don't have to dig it in or till it in, because if we dig and till solutions like this into the soil, then we risk both damaging the complex ecosystem that is down there, roots and filaments and hypnea from fungal systems and stuff like that. And secondly, what happens when you till and turn that soil heavily to work something into it is that there is already a lot of carbon locked into any soil. And when you get the carbon exposed to the surface, the carbon reacts with oxygen, and that reaction turns into carbon dioxide, which is CO2, that escapes into the atmosphere. So that's why kind of liquid nano clay and sort of getting to this specific liquid is sort of the story behind the name.
Interesting. And I assume that because it's called liquid, you break it down to such a small level that it can be almost like a liquid form. And how do you actually spray this on to the soil that you have? So I know that from the article that I read, your experiments are done in Dubai, where it's completely a desert, sand, and probably there's not much nutrition there as well. So, and to be able to mold these things into the actual sand that's in Dubai, how do you go about doing that?
Yeah, so let me answer the part on your sort of the liquid first. The second part about liquid is that the particles are so small that you will have them, and the reason why this is a good solution as well is because it's not about compacting the soil and just making it sticky so it sticks together by applying a lot of clay into it. It's really down to sort of the micro nano particle sizes of the clay particles, and something called cationic exchange capacity and the structural surface charge of the particles. Now we're getting very sort of scientific. So some of the audience may enjoy this. Others may think what is talking about now. But the basics of structural surface charge. Every particle has a kind of an electrical charge, and it works just like magnets, right? So charges that are equal, they will oppose each other, just like if you flip the magnets on the wrong side, they will push apart. And opposing charges will attract each other. So there will be opposing charges between these tiny clay flakes or plates. and the sand particles. So they will, like magnets, attach themselves around and create like a snowflake structure that expands the surface area around every grain of sand that is in your sandy soil. That creates microporosity, small porosity areas and aggregates in your soil that allows for air to come in, and allows also for water to come in. And now the second part comes in. It's actually the cationic exchange capacity and this surface charge that also helps you to retain the water in this situation. Because you don't want to clog up the soil so that it's just about sort of slowing down the filtration level or the speed that water filters through. Then you'll get other problems, right? Water will not come in, and when it rains heavily, everything will just wash over your land. You want to keep it porosity open so that it trickles into the soil and filters through. But you want to make sure that once you stop applying irrigation water, as an example on the top, the water will be retained. And if you apply more water than this soil needs, it will just continue going through. But it's then about reducing irrigation to keep the right moisture level. If you're on the side here would have a part of your land that was not treated, and you stop putting irrigation water on it, it would continue to trickle through, and then the top soil would be dry again, right? Whereas here it would be retained because of these, call it these magnets that I say, that also attracts and holds on to the charges of the water molecules. And that's sort of the whole concept behind our innovation.
Right. And if the water gets retained in these particles that are joined together with the sand, how does that, how does that kind of get the roots of the plants to absorb the water? Because if it's kind of trapped between the sand and the clay particle, then how does that seep into the roots of the vegetable?
Yeah, so the roots of the vegetables or whatever crop you're planting there, I mean they move for water, right? So wherever they will find water, they will get it, and they will have roots and small roots that form around them. If you drag up any kind of crop, you'll see that they have thick roots and thin roots. And very often they will have a symbiotic relationship with fungi and fungal networks, which are these very, very fine threads around them. Some of them are so small that you cannot even see them, and they can go for extremely long root systems around these plants. And they will find that moisture and have a nice uptake of the moisture. And the roots and the microbial life that is crucial for the exchange of breaking down nutrients to a level where the plant's roots can actually have an uptake of them, and where they exchange their sugars for various other nutrients, and this food web system that's happening underground here. Having a proper moisture level is also very crucial for that life to thrive as well, because when you have moisture in your sandy soil or in your soil in general, the temperature goes down and it becomes more stable. An easy way to compare it is just imagine going to the beach on a sunny afternoon and it's been extremely hot during the day, and you put your feet on that dry sand. I mean, you're just burning, and you just want to run, and you want to run either to where there is grass or to where the waves have washed up some moisture. And the moment you get to that moist area where the waves have washed up some water, it's nice and cool, right? Yeah. And that's what we see also when we've applied liquid clay that retains water and moisture in the soil, that the soil temperature is much lower, much cooler, and it remains much more stable. You don't have these peaks. And both root systems, fungi, and microbial activity, they enjoy better a more stable climate. They don't like these peaks, just like us. If you have to, all the time in and out of air condition and very warm outside, it's like it's what we enjoy the most. We continuously keep adjusting, and if it gets too warm, we get lazy and we fall asleep, or if it gets even too warm, we perish, right? So that's also how life underground works. And that is why this is such an impactful solution to both reduce water consumption by up to 50%, and it also stimulates better soil health, and it is very positive for the biodiversity underneath our feet. Of course, as you said, deserts may be scarce in nutrients at times. I mean, there is some soils that still have a lot of nutrients even in deserts, and a desert is not necessarily a damaged or degraded ecosystem. They are very complex ecosystems that you need to have respect for as well. So when you want to cultivate something there, you need to understand how you're impacting that ecosystem. But you will also need to apply some kind of organic matter in the process, or nutrients that is important to start to kickstart this process of the food soil web again.
Mm. And these deserts in Dubai, I assume that it is an arid land, and maybe, as you said, there is some kind of microbes living there, but probably not enough to sustain a vegetation. And so, what kind of nutrients do you actually provide these farms with? I'm assuming compost and other things will go into this.
Yeah. So we've been for the pictures that's been circulating around the web these days. That's been a validation project with ICBA, International Center for Biosaline Agriculture. We've done sort of a 2-year validation initiative so far, and we're just about planning the third initiative as well. So the first year we did look at grass and water retention and soil health development there, where we documented 47% water savings, decreased salinity in the topsoil, and increased biomass production. So then we went on to the pictures that we see now that were food crops, watermelons, zucchini, pearl millet grains, and there we treated the land with liquid nano clay, and we had 144 different plots and controls and reference plots to look at sort of with and without treatment. Basically, we apply some organic matter with sort of organic certified manure to have the needed nutrient starting point. For some of the plots, we also inject the liquid nano clay with fungi, with mycorrhiza fungi, to help boost the fungal activity, which is very positive for the symbiotic relationship. And we didn't in this validation project apply any. I mean, there is a lot of research and a lot of activity going on in microbial products and everything from laboratory created compost teas that select sort of the right microbes that are positive for whatever you're going to do. So we did the plan of these at this stage. That is something we also are planning to look into for the future. But for right now, I mean, the transformation of that little piece of desert land there happened with just a slight bit of organic matter in the preparation of the land, applying the liquid nano clay. Some plots with fungi and many of them without. Just to see sort of the difference on that. And within a couple of weeks and months, that land transformed from an arid desert sand surface to a green oasis with 2.5 meter tall pearl millet, green leaves and fruits and vegetables. And I mean, I walked around there myself in the end of March, and just before we had to depart because of COVID-19. And I mean, I felt the temperature of that sand in my shoes and sand in my hands, and just seeing this transformation is just such an inspiration.
Right. Yeah. I wish I could see that too. And before we started recording this, we talked about food security and self-sustainability within each nation. And for a country like UAE, or in particular here in Dubai, there's not a lot of I guess, water available. There's not a lot of these organic compost and different matter that requires to grow vegetation in that area. How do you see that Dubai being able to continue doing this without importing so many things from around the world? So let's say like water or energy. I'm sure they have no problem with that. Very cheap energy they can source. But in terms of water and nutrition, how do you think that they can continue with this?
Well, I think there are lots of things happening on water innovation areas in terms of treating gray water and black water and sewage water and all kinds of things that is going to be of high relevance. I think the UAE is sort of an admirable nation when it comes to innovation in general. I mean, just look at a small country like that sending off a mission to Mars recently, and opening when others are closing nuclear plants, they are opening new ones with new technologies for better safety and cleaner environments and stuff like that. So they're kind of taking a different path on many areas, which is quite inspiring to see. So if you look at the things that are happening on water, and even more newer technologies coming to play also when it comes to desalination of water, which today is both expensive, cumbersome, demanding a lot of energy, burning a lot of fossil fuels to get this done, and also creating some challenges with higher salinity in the water, where you're sort of focusing all the salinity that's coming out of the process. I think there are great innovations coming around to improve that and make that more sustainable and planet friendly and friendly. So then the next chapter is to make sure that we are not wasting that water, because if you look at the UAE, the biggest problem is that the majority of the land is arid land, desert sand, dune sand, and I mean, any water that you apply there is just going to keep trickling through. Another challenge with that, if you start to cultivate these areas and you start to fertilize them, also the fertilizers will keep trickling through. And even in these regions, there is also groundwater sources. Maybe they are deep down, maybe they are, so aquifers and groundwaters will also potentially be infiltrated by, nitrogen leaching if you start to fertilize and cultivate these areas and just applying huge amounts of water. So I think you need to work in conjunction here and actually make sure that you get healthy sandy soil out of this that retains the water and nutrients and works also to reduce and eliminate the negative impacts of leaching of nutrients and fertilizers in the process. So I think these things go hand in hand. And I think this is why also everybody talks about when you're bringing in new innovations to market, everything is timing, right? So if you come up with something that requires innovations that are not there from other sectors, your timing is off. Yeah. But with everything happening on these fronts together and the enormous initiative that we see around the planet for solving the big threats against humanity and prosperity to life on Earth, makes this right timing for all of these technologies.
Mm-hmm. And I know from reading different research reports and articles that Saudi Arabia and UAE both were experimenting quite a lot with greenhouses, vertical farming, and the only way that I think farming can be very sustainable is also with the affordability of it as well. And if you had to compare, the stresses on sustaining a greenhouse, use a lot of energy because you have to keep it cool down, and also the vertical farming where you actually do use hydroponics where there's a lot of usage of water, and then your liquid nano clay where it retains water and how do you compare the cost structures of that, and how do you think the viabilities are for those type of farming technologies?
Well, I think cost structures is one thing to look at, but I think there are wider aspects to consider as well, because there will always be cost the differences between a greenhouse infrastructure and an open field cultivation. I think if you also look at it at the same time in terms of the possibilities that you're bringing when you are cultivating larger areas. I think this is relevant both for agriculture and also for green landscapes and other things that are contributing to both reducing the water that is needed to keep the area green and fertile, at the same time reducing some of the other major issues that you have in places like this, such as dust mitigation, that you are cultivating much larger areas when you do it outdoors. You're binding the top surface, which is just loose sand. Also, back to my beach example of lowering the temperature of the surface. I mean, if you do that at larger scales, it will not just be the surface. This will reflect into the local region and the local area as well. And lowering ground temperatures and surface area temperatures at scale in areas like this will also have major positive contributions in terms of making it a more pleasant place to live and be in, and then reducing the overall consumption of electricity to cool down the areas as well. So I think you need to look at it from multiple angles to see sort of this at a larger scale. Secondly, I think we need all of these innovations really at the same time, because they will have their positive elements. And I think what I really enjoy is to see sort of a lot of initiatives coming together around how do we really get to the most nutritious and healthy food as well. And I don't think we have the answers there yet. I think aquaponics and greenhouses are amazing innovations happening around them. Greenhouses are not what they once used to be. I mean, there are ways where you have greenhouse innovative companies that are now stimulating the lives of pollinators like bees and everything, and doing a more natural approach to the entire process, using highly energy efficient solutions to keep the right temperatures and stuff like that. So a lot of things is happening in that area. But at the same time, we don't yet know the answers, and there are questions to be answered as well, such as why is food in general today less rich in micronutrients? And will we be able with these closed environments to change that and get the micronutrients back into these to the food that we're eating? Because what we don't understand, 95% of the species on Earth, on terrestrial land Earth, probably reside underneath our feet in the soil. And it's an enormous ecosystem and a very complex ecosystem of biological life that all work together. And there are probably wars going on there between some of these microbes and species, and there are the ones that are protecting the plants and feeding the plants, and all the nutrients needs to be broken down by various types of microbes and species there that are eating them and excreting them and eating each other, and then breaking it down until these micronutrients are exchanged for sugar with plant roots, with fungi and stuff like that. And are we able, with innovation and science and technology, to recreate nature's wonders of everything from photosynthesis to this advanced system down there? We don't have those answers yet. I have not seen it, so I think we need to think about ways to make sure that we keep on driving down paths of both working in harmony and concert with this amazing ecosystem in the soil. And creating sources of new innovations on the side through technologies such as we do within greenhouses and aquaponics and other areas.
Yeah, I agree. I mean, I think there's ways for many different technologies to survive in this world, and the amount of degradation that we cause this environment, we need to come up with more and more different ideas and different ways to recreate the world that we live in. At least maybe recreate, as you said, might be a little bit different because maybe it's some kind of God's work, but try to keep what we have right now and sustain the level of what we have right now, because our world is going to probably get more and more difficult to live in with the growing population and the need for various food sources. So I think that what you're doing in this farming sector, whether it's in deserts or it can probably go out into different types of arid lands in the world, and I hope that you can grow this business a lot more. So could you tell me a little bit more about what's next for Desert Control and how you want to go about growing your business?
Yeah, I think that the need for what we do is enormous because correctly, as you say, I mean, we're growing as a global population, and we know that just by the projection that we currently have, this planet needs to generate more food in the next 40 years than the planet has produced over the last 500 years altogether, right? So there is definitely need for all of the technologies. At the same time, we have desert spreading and loss of topsoil of something like, according to the United Nations, 12 million hectares per year of fertile land that perish to desertification and droughts. And 12 million hectares doesn't really say anyone too much. But if you break that down to something that we may recognize, the size of football fields, it's something like more than 30 football fields every minute that are just wiped out. So these are the challenges that we need to address. I know that the ability and creativity and adaptability of mankind and humanity is so enormous that we will overcome these challenges, and that's what we are focusing on in Desert Control as well, to be part of the solution to these problems. So what's next for the company? Well, we are still early stage, so we've been focusing sort of the first almost a decade really of early stage testing and validation. I've also spent many years of my life in the software and the IT services industry. So whenever you hear something has taken 10 or 15 years or whatever to bring out, so it's like, this what's going on? Because in the software industry, we can debug things that we are developing every hour or multiple times per hour. But when you're dealing with nature, you need a plant cycle or a calendar year between every bug fix. And then you also want to make sure that the long-term impacts are not going to be harmful in any way, and understanding what this will do. So you will maybe need like 2 times 5 years cycles to make sure that you have something that is really sustainable and positive to the environment. And then you need to get external validation, which is what we've been focusing on the last 2 years together with International Center for Biosaline Agriculture. Because if you only try to validate everything yourself, no matter how good your intentions are, sometimes you get biased and you get some intentional based outcomes. So it's super important to work with very professional, independent organizations to make sure you get good validation on everything that we do. We've spent 2 years now, the last 2 years on that. And prior to right now, we did not focus on then starting to build very efficient equipment or solutions to produce this liquid clay at scale, because you don't want to invest in something before you really have spent all this time to make sure it's the right solution. So we have sufficient validation. We know that the liquid nano clay LNC is working as we are expecting, and has the positive effects and no harmful side effects. So now it's time for us to start to scale up. So we raised a seed funding round short of $5 million that we finalized and closed March 20th this year. And with that funding, we are now focused on building the first prototypes of the scaled up versions of the production equipment that can produce this liquid nano clay in close to the areas, or actually on the fields that we are treating. because we don't want to have huge amounts of liquid shipped around the world. That's a very negative footprint to do so.
Yeah.
We want to do this locally. We want to be able to, hire locally and build, create jobs and opportunities in local communities around the world. That has the positive ripple effect of healing the land and creating more jobs in agriculture, saving water, producing more food, and all the other things that we talked about, and make that happen with circular economies and capacity development in local communities. So that's why we are focused now on really getting these first semi-autonomous business units of field process equipment developed. The first prototype is expected to go into testing now in a couple of weeks. Then it will be deployed in the UAE for field testing, some real operational experience with this one. And as it is, you always need to make some improvements before you produce unit number 2 and 3. And based on the engineering improvements of that, we will be ready to start mass producing these units and start to scale out. So right now we're in the scale up of capacity and then forming the business model around that to scale out into the markets in the next stage. That's what's next for us.
Awesome. Yeah. I mean, I'll probably have an opportunity to go to Dubai once all this international travel opens up. And I definitely want to have a chance to see your field and check it out. And I think what you're doing is awesome. It's great for the world and great for, revegetizing the whole world that we need so much. And I hope you very huge success in what you're doing. And hopefully this podcast will reach enough people so that you can also secure more funding, build more awareness, and get your word out there. So thank you very much for your time.
Thank you very much. And to whoever is listening to this, also we appreciate to get any ideas and suggestions. If you're skeptical to this or think there are ways that we should think about, we are so eager to learn and understand. As I said, we know as humanity so little about the advanced ecosystem underneath our feet. We probably know more about the moon and soon about Mars than we know about the soil systems and the complexity of those biological networks that are happening there. We are just so happy, and it's such a fulfillment to work with this. And we're on a mission to make this planet more green and sustainable and resilient to ensure prosperity for the life and all life on this planet. So thanks for having me on your podcast.
Yeah, thank you very much. Hi, this is your host Takatoshi Shibayama. Thank you for listening all the way to the end. Now, if you enjoyed or disliked the show, please let me know by writing in the comment section. The only way I can improve or add value to you is through your voices. If there are any topics that you would like me to pick up, please also let me know in the comments. I'd love to start chatting with you all. And if you would like to continue watching the show, please subscribe. Thank you.